Okay, this is another moment that when we met as a teacher and the students, or as the lovers of electronics and telecommunication engineering. I would like to take this opportunity to welcome some physical engineering students into this class, and also I would like to take the same opportunity to welcome online students into this very interesting, because today we are going to dive into workshop. So we are going to dive into workshop 5, and this is all we are going to discuss in this workshop about encoders. So my name is Olenjolain. It's the first time to meet me. I'm very happy to have you. I'll try my level best to make sure that I teach you a very important concept concerning about encoders. However, that I will not actually going into the depths, because we will be paying the attentions. We are heading to the designing of RF transmitter, which can transmit the information with a carrier signal of 433 megahertz. Actually, I'm going to lecture you, or I'm going to provide you some theoretical concept, especially at the beginning of this workshop. But later on, when we dive into the middle of the workshop, I'll be just giving you the practical information, and especially that in hardware implementation rather than in simulation. So I will give you the concept of what are the encoders and how do we define them in electronics perspective, and also how we use them in telecommunication engineering. But again, I will just be focusing on how we can use it or we can apply it in designing the RF transmitters as one of the communication system. So I would like to ask you that this will be the theory, but we are heading to the practical one. You have to concentrate, you have to listen, you have to ask questions as well as you can. And I would like just to tell you that for the beginner and intermediate students, I would like to ask you to pay attention and concentrate, because once you understand about these 4 concepts that you are heading about, encoder and 433 megahertz RF transmitter module, and also when you understand about decoder and the 433 megahertz RF transmitter receiver module, then you can actually connect them together, and you can have a distant transmitter and a distant receiver. So those are the pre-information overview which I'd like just to give you in order to make sure that you pay attention. I know that some students, because I've been teaching them a number of workshops, a number of lectures, they can take it as just, we have experience, it's just, we are just going to get the information. But I want to tell you that don't have such kind of the mindset. Take into considerations and concentrate. So if that's the case, let me just appreciate some physical students, and then we'll go to start our today's workshop. I'm sorry, my voice today is not good, and not even my voice, my health also is not good, but I thank God because He's just giving me strength to make sure that I have to accomplish His business, because what I'm doing, it's an assignment that makes me to be alive. So as long as that I'm alive today, I have an assignment to do. So how are you, students? Are you ready for workshop 5? Are you ready for chapter 6 encoders and 433 megahertz RF transmitter module? A. So if you are ready, just read the chapter 6. What are the names of the chapter 6? 1, 2, 3, let us go. Read it loudly. 1, 2, 3, let us go. Yeah, so this is the broad concept in telecommunication. Today we are not going to have any quick review because it's a new topic. So we are going straight forward to start the concept and actually try to build something in our mind. Encoders, so we are going to start with the word encoders or encoder. So you can define as a plural or you can define as a singular. Say encoders. Encoders. So the word encoder comes from the word encoding. Okay? But when you analyze this, it's actual that you can find that we have a prefix which is en, but also we have something which we call the code, which is related with computer programming, and then we have suffix which is rs, in terms that if you want to analyze the word grammatically. Okay? But simply, we mean that we like just to, in case of the encoders, the theme is just we want to provide a particular code into the information signal before transmitting it into the airspace. That's the simple concept or the simple idea. Why? Because the space is just open. So we want to provide security or provide, it means to provide security and unique addresses whenever we transmit the information into the airspace. So the airspace, there's a lot of information signal transmitted by satellites, information signal transmitted by RF transmitters, information signal may be broadcasted by radio transmitters, information signal transmitted or propagated by the microwave dishes or microwave links. So in the airspace that we have a number of information signal. So how will the system distinguish that which type of the signal has to be received or has to be allowed to transmit, to travel from one point to another point? So one of the techniques that we are using in telecommunication is actual encoding. So encoder, it's a noun. Encoding, it's a verb. Okay? Yeah. Okay, wonderful. So the fundamental question, I say that in digital electronics, in the fundamental digital electronics, you learn encoders in detail. Also in digital electronics as one of the modules, which is actual, the prerequisite is fundamental of digital electronics, you may learn it in detail about types of encoders, about the term. But for this case, we are going to, yes, I'm going to give you the introduction, the introductory concept, and build a strong foundation. Then we'll be heading to the practical because we want to use it to encode the information signal. So right now, we'd like to know that what is encoder? Or what is encoder integrated circuit? I think that we just will discuss in later on. We said that an encoder is a digital electronics circuit. So this is the digital electronic circuit that conveys or conveyed a set of inputs into a unique binary code. Into unique binary code. So this is the one of the definition of encoder. What is encoder? Simply, this is the digital electronic circuit. Say digital electronic circuit. So what does it perform in digital system? Well, it's conveyed a set of inputs or binary inputs, a set of binary inputs into a unique binary code. So you see the word code, and this word code, hello, stop writing. You see the word code, and this word code is found here in this word of encoder. So it means that in case of the encoder, will have the binary inputs supplied to the encoder, but the output we expect to have a unique binary code. So when you say unique binary codes, regardless that you have maybe thousands codes or billions codes, so each code will be unique. Can I repeat? Okay, I say, this is the digital electronic circuit. For instance, that this is encoder. Let me just use drawing to explain the concept. This is the encoder. So in case of the encoder, it means we'll actually apply or supply binary inputs. So binary inputs, it depends. And then what you're expecting at the output, we expect to have unique binary code. So we introduce binary inputs such as 0 and 1, but also at the outputs we are going to have unique binary code, which might be completely different from what you have supplied at the binary inputs, because these kinds of decoding will be performed within the encoder. So what I was telling you, that you see that in case of the binary or in case of the encoder, actually we convert a set of binary inputs into the unique binary code. So I say that the inputs is binary, so it means the digital information. But the output, it's unique. Say unique. Say unique. Ask your neighbor, are you unique or you are common? Ask your neighbor. Ask again your neighbor, in this world, are you unique or you are common? Ask again your neighbor, are you unique or are you not unique? And reply your neighbor's question. Who are you asking? Hey, you are providing the attendance. So when we say unique, regardless that we have how many information signal, but the encoder has ability to provide the unique information signal. So we say that unique binary codes, it means that we might have maybe billions or millions of informations in the airspace, but each information signal which has been passed through the encoder will be encoded in such a way that that information signal have its own unique binary code, which actually you can use it to distinguish from another set of other information signal. This is one of the definition. Some of the sources also define the word encoder are this one, that encoder. So in some of the sources, it's called also binary encoder. We call it encoder or binary encoder. Who is talking? This is the combinational. This is the combinational. Is a combinational logic circuit that is used to change. That is used to change the applied inputs signal, applied input signal into a coded form at the output. So encoder or binary encoder, this is the combinational logic circuit that is used to change what? The applied inputs signal into what? Coded form. At what? At the output. So these are the two ways that we may define the word encoder. So separating, let's now reinforce understanding because these are the important information. There's no need for you to crave them. You just write them in your memory, and then you remember them for the rest of your life. So let us read the definitions while we are trying to write in our subconscious mind so that we may not forget. So 1, 2, 3, let us go. What is an encoder? So some have been heading ahead, and some of them have been lagging behind. So 1, 2, 3, let us go. An encoder. And 1, 2, 3, 4. Let us go. An encoder is a digital electronic circuit that conveys a set of binary inputs into a unique binary code. Or what is encoder? So when you allow the digital signal to pass through the encoder, what do you expect at the output of the encoder? Pardon? According to these two definitions, first of all, what do you expect to be the input of the encoder? Tell me the input of the encoder according to those two definitions. Binary, 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 binary code. Where it has been mentioned binary code there. Binary, there's a difference between binary inputs and binary code. Binary inputs, it's different, it's not equal to binary code. Because I see that you think these are the same, the same terminologies, no? So what the input from those two definitions, what are the inputs of the encoders? Binary inputs. Where are those binary inputs come from in case of the real situation, so real world situation? Where do we get those binary inputs? We say that the inputs of the encoder, you say it's binary inputs. It's true. Where do we get those binary inputs in case of the real world situation? From this distance, where do we get those binary inputs in case of the real world? Okay, so you don't. Communication signal. Thank you. We discussed in workshop 4, we discussed in workshop 3, we discussed in workshop 2. But you are sounding like you have never heard. Good. Then, what is the outputs of the encoder? According to these two definitions. What is expected output from the encoder? Binary code. So ask your neighbor, what is binary code? Edison, are you in the class or you are somewhere else? Are you at Mbagala? Are you in the class? Why are you not talking with your neighbor, Toba? You will talk with him. I don't see that, I don't hear that you are talking with him. You are trying to sing. So encoders are made in form of through-hole, integrated. Keep quiet. Integrated circuit. Oh, I see. Also, this one are made in terms of surface mount device. simply integrated circuit. Simply call it SMD IC. So in physical implementation, we say that encoders are made in terms of integrated circuit. And we have two types of integrated circuits. You have through-hole integrated circuit, and also we have surface mounting device integrated circuit. So that's what you expect. You expect to find encoder, it's not a discrete component. An encoder, it's made in terms of integrated circuit. Say integrated circuit. Again, say integrated circuit. Say loudly, integrated circuit. So you say again, simply the encoder integrated circuits combines more than one bit to produce a single coded series of bits. If it is used to receive parallel input data, and provide the output signal as a series of the data. As a series of the data. So again, we have 2 points to note. The first one, we say that the encoder integrated circuits combine most of them combine more than one bit to produce the single coded series of bits. For that case, these are encoders. They receive the parallel, inputs data, and provide the output signal as a series of their data. That is good. So what does it mean? However, that you can find some encoders which have more than one output. And also you can find some encoders which are actual that have only one input. So it depends to the architecture. Listen, separating. If let's say that this is an encoder. What does these two, or what do these two sentences mean? Then we say that we can have maybe 4 inputs. So these are the inputs that will input the binary bits, and then we have a single output. So for this case, suppose that we have BT1 here, BT0, maybe we have also BT0 and BT1. So these codes, I taught you in previous workshop about about parallel in, serial out. But let me remind you, because this is the point where we apply that concept. So you have inputs, so you have bit 1, bit 0, bit 0, bit 0, bit 1. So these bits will be supplied in terms of parallel. That's the parallel arrangement. Okay? And then they'll be processed or they'll be coded. They'll be coded by Zoti. This is encoder. So the encoder will code it. Okay? This is the encoder. So the encoder will encode the information signal. So once it will code the information signal, the output stream is just a single one. Or it might be, there might be two. But remember, whether it is we have a single output or we have two outputs, remember the inputs actually had the 4 bits, which are being introduced to the encoder in form of parallel. So for that case, at the output, whether we have a single output or more than one output but less than 4 outputs, what do we expect? We expect when these bits will be supplied, they'll be encoded, each of them will be encoded, and then we'll have bits in form of 40 of, so it means that we have the first bit, and then we'll have the second one, which is in series, the third one, and the fourth one. But remember that this is binary inputs, so these are the normal bits, but these are encoded encoded bits. When you say encoded bits, you can find that we have bits, but also they have an address. That's what we call them, and they have the particular code for that particular encoder that has been provided by that particular encoder. So you see that it's 1001, but it's encoded. For this one, it's an encoded information. Are we together? Are we together? Sometimes we may have, because I will show you the principle or the mathematical formula used for the encoder. You can have what? You can have an encoder which has 4 inputs, let's say, and then you have 2 outputs. So what is happening for this case? These 4 inputs, because will be connected, interconnected, so with the one of the source of the binary inputs, which might be either digital sensor, or it might be as maybe just different microphones or whatever, different sources of the information, so voice signal, but also intermediate in between, should have analog to digital converter. So suppose that for this case we have 0, we have 1, and then we have 0, we have 1. So these 4 bits will be applied in parallel. So these 4 bits will be applied in parallel, right? Right? So once these bits have been supplied into the encoder will receive those bits in parallel and then encode the information, provide the unique code. Then for the output, we will expect that the 2 bits will be given out in this stream, which is 0, 1. And also the 2 bits, the first one will be 0 and 1. So you see that the 2 bits will be given out in series. And for this case, the 2 bits also will be given out in series. So simply, when you say that about what? So this one, we say this is actual that parallel, we call it parallel in, serial out. Similarly for this one, we call it parallel in, serial out. So you should not claim that maybe the output of the encoder is always 1, no? But the output of the encoder that you're going to learn in this module is actual. We have only 1 output. But you can find some encoders, they have 2 outputs, 1 output, 2 outputs, 3 outputs, it depends. 4 outputs, it depends. But remember that at the output, the bits are given out, or the binary codes will be given out in terms of serial arrangement. Are we together? Are we together? Are we together? If you have a question, you may ask it. So the general form of the digital encoder, the general form of the digital encoder, the general formula, let's say that formula, the General formula of the digital encoder is 2 power n to n. So that's the general formula that we use in designing, we call them fundamental digital encoders. Fundamental digital encoder. So for this case, you say that whereby n is number of inputs. Number of 40 of inputs. So for this case, once you have this mathematical formula, we can have some examples of encoders. Examples of encoders. So writing, the first example for an encoder will get when the value of n is equal to 0. So when the value of n is equal to 0, we're going to have 2 power 0, then dash to OT, n is equal to OT, 0. So we don't have encoder for that case because we'll have a single input and 0 output. So when n is equal to 0, it's not OT an encoder. So for that case, we have to put a condition whereby n should be greater than or equal to 1. Are we together? Are we together? So this is not OT an encoder. I just showed you. So we say that the first encoder, say when n is equal to 1. So when n is equal to 1, we're going to have 2 power 1, and then 2 dash, then n is equal to 1. So 2 to 1. So the first example, so we have what? We have 2 to 1 encoder. Then the second example, we say that when n is equal to 2. So for this case, we have 2 power 2, then dash 2. Stop murmuring, please. So 2 power 2, this makes 4 to 2. So this one, we call it 4 to 2 encoder. So what does it mean? For this encoder, 2 to 1 encoder, we have 2 inputs and 1 output. Are we together? And what does this one mean? We have 4 inputs and 2 outputs. So having 2 inputs means that the binary bits here are supplied in parallel. Having 1 output means that the output bits will be actually given out, or the encoded information will be given as a series or sequence of 40 of binary coded. For this case, the 4, so if you have 4 inputs, we can supply 4 bits simultaneously. Or you may supply 1 bit among, just 1 bit at the 1 input. You may supply 2, you may supply 3, you may supply 4. But the outputs will be given just in series, where that we have only 2 outputs. So the 2 bits will be given in 1 output terminal, and also the other 2 bits will be given in series on the other output terminal. Are we together? Yeah. So you have to understand. You should not claim this information. Then we say that the third example is when n is equal to 3. So when n is equal to 3, we have 2 power 3, and then this one to 3. So 2 power 3 means what? 8. So for this one, we call it 80-2 3 encoder. So how many inputs do you have there? 8. And then how many outputs do you have? 3. So how do you think? So 8 bits will be supplied into encoder. 8 binary inputs will be supplied into the encoder in parallel. How are we going to have these 8 bits at the outputs with 3 output terminals? How are we going to have them? Eh? I say that for this case, we are going to have 80 binary inputs in parallel, right? But our output terminals or our output streams are 3. How are we going to get those 8 bits from the 3 output terminals in terms of series? How are they going to be divided? Because for this case, it's simple for you because you have one output. For this case, we have what? 4/2. 4/2 it is 2, right? So expect 2 bits in one stream and 2 bits in another stream. But for this case, if you take 8/3, you get what? 8/3. A is indivisible. According to Johanna, 8/3 it is indivisible. Clap your hand for Johanna first. Johanna is not in this class. 8/3, it's indivisible. 8/3, well, you get it 2, and then you have 22.60. It's a repeating decimal. We taught you in the first topic of basic mathematics form 1. And then you say it is indivisible. But you tried, right? Rather than somebody who said nothing. Okay, good. So how are you going to have the outputs now, the bits? So you're going to have 2 bits or 3 bits or what in one stream? 2 bits. And then, how about the other 2 bits which will be remain? They are sure? You assume? Okay. Then, the first example is when n is equal to 4. Then for this case, we are going to power 4 to 4. Then 2 power 4, it is 16 to 4 encoder. So having the even number of encoder, it's not a problem. Because for this case, you know that we have 16 parallel input bits. And they have 3 or 4 output terminals. How are we going to receive the binary bits at the output? How? So for this one, it is simple, according to Jessica. Isn't it? Jessica, 14/4? Jessica is not in the class. Pascal Joseph, 14/4? 4. 14/4? Master, 14/4? 3.5. What Joseph Pascal has prepared is 16/4. And I did ask that question. Daniel Fortunato, 16/4? Daniel Fortunato, 16/4? 4. So it means that we expect 4 serial bits in each output stream. You should not claim that all the encoders which have 16 binary inputs will have 4 coded output. No. You may have a 16 binary input encoder, and all the 16 bits, if you supply them, they can be given out in one streams in series. For instance, the encoder that you're going to learn, its inputs are 4 inputs, and hence the output is just 1. So you may supply 4 bits in parallel, but the outputs will be given out by using one output. Okay? Are we together? Okay. So let us narrow the concept. Let us narrow the concept into more practical for the electronics communication laboratory. So then we know the definitions of encoder. We know some examples of encoder. We have a number of different types of encoders. We have priority encoders. We have a number of them. The encoder, it's a huge subject because it's very important in case of telecommunication and a special wireless communication system. So actually it's a broad concept. Don't think that you may learn it once or twice or just by going through 3 lectures or 4 lectures. No. Actually, that you may spend even 4 years and going through it and you haven't covered what you are supposed to cover. So then the next concept which you need practically, in case of for the practical purpose, It's a general block diagram. What the general block diagrams of encoders. It means how the electronics components or digital electronics components which are used to design encoders are arranged. General block diagram of encoder. So this is for all encoders. Soon we are going to narrow into the particular encoder. But for the time being, let us be general. Maxina. How about Latifa? Say general block diagrams of encoder. Say it. Again. Again. Okay, so ask your neighbor, how many block diagrams does Olenjolain taught you up to this time? So ask your neighbor, how many block diagrams that Olenjolain has taught you from semester 1 to semester 2? How many? So ask your neighbor and then let your neighbor answer you. 1, 2, 3, 4, 5, 10. So what did your neighbor say? Many. Uncountable. No, countable. Joanne, how many block diagrams have I taught you? There are many. How many? They are countable. For instance, if I give you 100,000 Tanzania shilling, can you count? Can you say that I have much money? Can you say that? No, you can count 1, 2, 3. It's simple within just a fraction, especially for Chaga. Do you think that a Chaga man can't count the money because it's a money? No. Even yourself, can't you count the money that you receive for your boom? No. You know, even 50 shillings, you just know 50, the coin of 50. If it has been lost in the daladala. Okay. So let us, we always think about how we can power. So then the first block is called what? If Olenjolain taught you a lot of block diagram. The first block is what? Power supply. Power supply what? Unit. That's the political answer. You didn't understand it for the digital case. So until I gave you a technique. So DC, power, supply, unit. But sometimes if you have the electronics component, you may try AC. What will happen if I introduce AC? But if you have the electronics component, because it's better to see rather than to hear. DC, power, supply, unit. That's the first block. The second block, what do you think the second block? Input. Very good. Clap your hand for her. Clap your hand for her. Wow. So input unit. Remember that regardless of the complexity of the system you are thinking about, in case of the general block diagrams, it means that always the input should be there because what will be processed? Okay. Then for the encoder, we have a new block that I have never spoken about it because I was waiting for this time. All the encoders have a block, we call it address unit. Say address unit. Address unit. Again, say address unit. Address unit. Because you say that it will give us the binary coded information. How will it give us the binary coded information? So up to now, we have covered a lot of block diagrams, right? How about semantic circuit diagram? How many did I teach you? Many. Did you understand all of them? No. Some. Okay. And what is your plan? Eh? So this is encoder. That's another block. And then once we have that, the encoded information, we are going to have another block, which we call it TOT, output unit. So this is the structure of the encoder. Happiness, what's going on? This is the general block diagrams of an encoder IC. Let us add this word right now because you've understood. So the IC that will be have in your hand, with internally, this is what we expect it to have. Or these are the main blocks that we expect to have within the encoder. When you say that the input unity, we don't mean that from maybe a digital sensor or whatever, no. We mean the input unit of the encoder itself. The encoder has its own input unit. The encoder has its address unit. The encoder has its output unit. And the encoder needs also the C power supply for it to encode the information. Are we together? So just to help you to understand, you know that this is the structure of the integrated circuit. Stop writing and stop drawing. So this is the structure of integrated circuit. So in case of the through holes, it's black in color. It's actually small in physical size. So what we have drawn, all of these blocks, all of these 5 blocks are within this integrated circuit. Are we together? Are we together? Are we together or we are not together? Eh? Not together. Some of you, we are together. Some of you, we are not together. Let me repeat. I said, or we say that all encoders are made in terms of either through-hole integrated circuit or surface mounting device integrated circuit. So the simple concept you should have in your mind, encoder, it's a digital integrated circuit. It's not a discrete component like a resistor. It's not a discrete component like a capacitor. It's not a discrete component like a PN junction diode. It's not a discrete component like a LED. It's not a discrete component like a bipolar junction transistor. It's not a discrete component like maybe MOSFETs. It's integrated circuit. What it means of integrated circuits? Integrated circuits, you say that this is it's electronic circuit that consists of different electronic components or different electronic discrete components that perform particular function. Are we together? Because once you learn a concept, you have to ask yourself a question. How does these components exist? Is it integrated circuits or it's a discrete component? Get through that? So this one, it means that the impulse will be supplied to the encoder. So this is encoder unit. And then for the power supply, we just need it to the encoder. And then we have the output unit. So what we have done, actually, we opened the IC or the encoder integrated circuits and come up with those 5 blocks. Get through that? Come on, please, with your stuff. Quickly. Class, are we together? Okay, so this is figure 1. Ask your neighbor, do you like block diagrams of electronics? Eh? Gertrude, I called you. Ask your neighbor, do you like block diagrams of electronics? See. Do you like? Do you like or you're not sure? So what did your neighbor say? Does he or she like? Johanna Samandito, let us take a sample. Do you like block diagrams of electronics? You are the one who have asked me. English. Johanna Samandito. So another point to note before we go into the particular. Hello, keep quiet please. This is another point that you have to note in your learning journey of digital electronics. We say that every encoder IC is made in pair with the decoder IC. This is the very important sentence. Read it. 1, 2, 3. Read it. Again. 1, 2, 3. Read it loudly. Are you sure? So is it clear? What? This concept is very, very, very simple to understand. God has given me a wisdom to teach students in a very simple language. Every encoder, very simple language. Just wait, I will teach you by using a very simple every encoder IC is made in pair with decoder IC. So to understand these concepts is very simple. How? It's very simple. I think every student in this class wear shoes. Say shoes. How do shoes exist? So shoes exist in pairs, isn't it? So a lefty shoe is equal to the right shoe? No. Can you wear just a single lefty shoe? No. If you can wear it tomorrow and show us, because you have a class tomorrow, and then show us today, I wear a single type of 40 of shoe. Or if your neighbor say that he or she can wear, check please your neighbor's shoes. Are they left and right? Check. Do you have any students who wear actual lefty, just a lefty shoe? Show us. In Tanzania, in case that you find somebody who wears just a one type of shoe, what do you define? Something is wrong, something is wrong in the mind. Mindless. Johanna said that person is mindless. Okay. So in case of the encoder and decoder, this is what we say. If, for instance, we have encoder at this point, let's say encoder 1, we expect it to have decoder 1. Listen. Hey! So this is equivalent to the left shoe, and this is right shoe. Can you wear maybe a rubber left shoe on one leg, and a sandal on the right shoe? Can you? Can you? Can you wear two different types of shoe? Who? Show us. Huh? No, everybody wear the same type of 40 of shoe. So for that case, that is the principle of designing encoder and the decoder. They are designed in terms of parallel. So for instance, if this encoder is equivalent to the rubber, say rubber. Rubber left shoe, this also should be rubber right shoe. You cannot have a rubber left shoe and a sandal right shoe. You can wear at home, but not actual outside of the place where you're living. Because once you are in Bongo, we try to predict that something is wrong. And even yourself, you won't feel comfortable, isn't it? So if you have an encoder, listen now, if you have an encoder A, also if you expect a decoder A, that will encode the information from encoder A. The information of encoder A cannot be decoded by decoder B. Also, if you have decoder C, and on this side we have encoder F. Encoder F can encode information, but decoder C cannot decode information encoded by encoder F. That's what I was teaching. Is it clear? No. You said you have understood because you know the principle of shoe. That shoe are always wear in pair and same pair. I asked you a question. Can you wear a rubber left shoe and a sandal right shoe? You say no. Similar for the encoder. So if you have encoder F, say encoder F. Say encoder F. So encoder F has its particular information which are not found in decoder C. So encoder F can encode information, but the information encoded by encoder F cannot be decoded by decoder C. It can only be decoded by decoder F. Alquino, you are alquinoning. Huh? So if you have encoder R, we expect the information to be decoded by decoder R. The information encoded by encoder R cannot be decoded by the encoder A. That's what I was teaching. Are we together? So encoders and decoders are made in what? Pair. Those are the practical information. It's no longer the theoretical information. So if you're using a particular encoder, you should have to know its corresponding decoder. And this concept is very simple. For instance, I write a letter to Joan Mush. And then my address box is found in DIT, and Joan also is found in DIT. But the destination address, it's Joan. So Joan has her own address, right? So the letter that I'll be writing to Joan, actually it will be found in Joan's address box only. It won't be found in Alquino's address box. So for myself who have written a letter to Joan, I am an encoder. And Joan, it's a correct decoder. Once Alquino see the letter or receive the letter that has been written with the destinations to Joan, then Alquino will say that, no, this is not my letter because it does not possess my own address. But if Alquino is faithful, because if he's not faithful, he say, hey, this is the chance, this is the good chance, this is the good luck. Maybe there is a man, let me check. Are we together, class? Eh? No, what? Who say no? Who say no? So I can help you quickly, then we move. Pasco? Or Peter? Okay, so now let us have our detailed discussion about one type of the encoder that we are going to use, or we have to learn in this module, and we are going to use it for the practical purpose. So now we are heading to the practical information. And one of the encoder that we are going to discuss, this is called the Ht12E encoder. Encoder integrated E circuit. Say Ht12E encoder integrated circuit. Say it loudly, Ht12E encoder integrated circuit. Okay, good. What is it? What is Ht12E? So E standing for the encoder. E is the first letter of the word what? Encoder. So Ht12E encoder IC. So simply say that the Ht12E encoder, we say that is an integrated circuit that has four inputs, data pins, and the eight address pin, 8 address pins to receive 4 binary input binary input bits encode them to provide a series of binary coded RT. It's a so this is the simple definition of the word Ht12E encoder. So Angelina, where is the Alquino? Huh? Where is the Alquino? Go and clean quickly. Okay. So Ht12E encoder, we say that this is an integrated circuit that has 4 inputs data pins, stop writing, 4 data pins and the 80 address pins to receive 4 binary inputs or binary bits, encode them to provide a series of the binary coded at the single outputs or at the single output. That the meaning of these types is a special purpose encoder where that it has 4 input pins or input data pins, and also it has 8 address pins, and then it can receive 4 binary inputs, that's the maximum. Can receive either 1 binary input or 2 or 3 or 4, but maximum is 4. Then once it receives 4 binary input bits, then encode them to provide a series of the binary bits at its output. Are we together? So let us reinforce the comprehension. So stop writing. Let us read this definition and extract some keywords. So 1, 2, 3, let us go. No. Restart again. 1, 2, 3, let us go. There are students who have been waiting output. Once you approach the output, then you see the amplified signal output. So simply, this is it's one of the types of the encoder. It has almost 12 input pins, input data and address pins. It can receive the maximum 4 binary input bits in parallel, encode them to provide a series of the binary coded at its single output. So it has 4 input data pins and it has a single output data pin. But also it has 80 address pins to provide address to the information signal which has been supplied to at the input. Are we together? Are we together? Are we together? Okay. So the Ht12E encoder is the encoder used to encode the communication signal or information. So now, block diagram. What is your neighbor talking? Are you sure? So block diagram of Ht12E encoder IC. That is block diagram number what for today? Number 4? Number 2. If we add with the previous block diagram, how many in total? 17. Since semester 1, 17 block diagram. Or just is only semester 2? User. What the first block? Power supply. You're expert to mention DC power supply. Very good. But I did the work to write in your mind because your mind was busy. Robert. Then the next block is what? Are you sure? So what will be the input of the encoder? The next block is called what? In semester 1, you have learned how to design oscillator. Do you still remember how to design oscillator? In semester 1, you have learned how to design oscillator. Okay, so this is the block diagrams of the Ht12E encoder integrated circuit. Stop writing. With that block diagrams, how many blocks do you have? How many blocks do you have? 7 blocks. The first block is actually called DC power supply unit, and the main and the primary function for this block is actually to power the integrated circuit. However, come back, have your seat. And then also we have the next block, which is input unit. So we have a next block which is input unit, and the other block is called oscillator unit. And the other block is called the address unit. Say input unit. Input unit. Say oscillator unit. Oscillator unit. Then say address unit. Address unit. And then you have the block which is actually will be encoding the information, but with the support of oscillator unit and address unit, because this is the uncoded information. So this Ht12 encoder unit actually will encode the information with help of oscillator unit and address unit. Yes, Ka? Explain what I've been explaining. Should I call Mr. Zakaria? So this is Ht12E encoder unit. And here we have So this is called what? Output unit. Yes, call Mr. Zakaria and tell what's going on. Carolina? Raise up your hand, Carolina. Mabeza? She's there. Alphonse? 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 So listen, this is the C power supply units. It's actually be supplied outside of the integrated circuit. But when we talk about input units also, we have the input units for the integrated circuits, but we have input units from the source. I said stop writing, stop drawing. When you talk about oscillator units, in case of the Ht12E encoder, we have two types of oscillator units. We have built-in oscillator units, and also you have external oscillator units. Right? So he said that built-in oscillator units mean that there's an oscillator circuit which has been built in within the Ht12E encoder IC. When we talk about external oscillator units, mean that we'll be connecting some electronics components. So it means that this oscillator, built-in oscillator unit, will be work with a company, or with it means that will be work in a company of 40 external electronics components. So for instance, in case of the external oscillator units, we'll be just having a resistor of the particular value according to the data sheet. And once you use that oscillator, once you use that resistor, then the built-in oscillator will be actually oscillating in the particular frequency in order to make sure that the information will be encoded itself. And then you have another block, we call it address unit. Say address unit. Address. So this block of address unit is built in within what the integrated circuit. What the main function of that block is actually provide address to the information signal. Because remember that in case of these encoders, we are not introducing carrier signal. We are not introducing actual modulated signal. We are just introducing pure information digital signal. So you have to make sure, you have to differentiate, because for up to these times, you know that there is an information signal, which is low frequency. There is a carrier signal, which is a high frequency. There's a modulated signal, right? Which is actually the 40 superpositions of 40 information signal into the carrier signal. So in case of these encoders, we are not talking about the carrier signal, because carrier signal, first of all, is analog signal. We're not talking about modulated signal, because modulated signal is analog signal. We are talking about digital signal, which is actual high or low, 1 or 0, true or false. That's all. Okay? So the main function of this address unit is to provide address. Say address. Address. Say address. How many of you have written a letter and sent it to the postal office? Raise up your hand. How many of you have written a letter? Where's the application letter or a friend letter? And they've sent to the destinations by using the postal office. Raise up your hand. No, raise up your hand in this way. So I see one student, two. So only 2 students who have written letters. So how do you used to communicate in terms of text? Message, What if you don't have destination number? Email. What if you don't have destination email? No communication. Sure. But you have the postal address. Do you think that every office or every institution or every college or every school, they have an Instagram account? No. Yes. What research did you do? For instance, myself, I don't have an Instagram account. But according to your sentence, you said that all the people have Instagram what? Account. So when you talk about address for that case, hello? When you talk about address for that case, it's a new phenomena for you. But during our age, for instance, myself, when I was in primary school, yes, in primary schools, when I was standard 5, 1995, when I was standard 5, we used to communicate by using letters. We didn't have phones, by the way. We need to have telephones. There's no mobile phones. There's no telephone by that time. We just communicate through the OT, through the letters. And that system has gone through until 2008. So 2008. So 2008, when I've gone to my A-level education, actually that we have been using, I received the information from the postal address. So, but the simple, so I know that in Swahili language and English, you have learned about how to write a friend letter and English letter. You heard something about address, but you haven't seen its importance because you haven't applied in your life. But your mobile phone number also, it's a unique address. Say unique what? So then we have a Ht12E encoder unit. It will be receiving the input unit and encode them, depending on the type of the encoder. Then you have the output unit. Then we'll take the encoded bits or the encoded binary information and then transmit it to the next digital system or to the next, or maybe in most cases, we say that towards the RF transmitter. Okay? Okay? Class, are we together? Okay. So now let us refer the manufacturer's mindset, features of Ht12E integrated. What are the features of this IC? Is there a question? Who was knocking? Is there a question? Say features. So these are the electrical characteristics of 40 of this encoder, Ht12E integrated circuit. So these are the features. Whenever we talk about digital circuits or digital integrated circuits, we have to talk in terms of bits. Say bits. For instance, this one, we say in case of the input, the maximum number of input is 4. Then the maximum number of pins for the address are 8. For the address, you have to use all the 8 pins. For the input, it depends. If you have a single input, you may use just a single binary input pin. If you have 2, you may use 2 among the 4. If you have 3 inputs, you may use 3 among the 3 pins among the 4. If you have 4 different binary inputs, then you may use all the inputs. Right? Are we together? So for this case, you have what? You have 4 choices. You have 4 choices, either having 1 input or 2 inputs or 3 inputs or 4 inputs. So the first feature is very important in digital electronics. We say that Ht12E IC, it is 12 bits binary encoder IC, binary encoder integrated circuit. How many bits? Say 12 bits. 12 bits. Say 12 bits. 12 bits. So this is 12 bits binary encoder. Also, encoders and decoders are known in terms of the bits. We have 4 bits binary encoders. We may have 8 bits binary encoders. We may have 12 bits binary encoders. We may have 16 bits binary encoder. We may have 18 bits binary encoder. So we have a number of encoders, and we define them in terms of their binary bits. What the meaning of these 12 bits binary encoder? Well, so the meaning is, according to this encoder, it means that we have 4 input data pins, and then plus 8 address 8 address 8 address pins. So that's what makes them to be 12. 8 plus 4? 8 plus 4? Mugisha, 8 plus 4? He's thinking. Yes, he's still thinking. No response. Huh? He's still thinking. 8 plus 4. Digna now, let us come back to you. 8 plus 4? No idea. Kankesha?
8 plus 4. 8 plus 4.
Yes.
8 plus 4.
I said 80 plus 4. 8 plus 4? 12. That's why I call it 1240. 12 bits. Your mind is amazing. Then this encoder, it has only 4 binary. It has only 4 binary data inputs. And also, it is commonly, we say that it is commonly, another feature, important feature, commonly used for RF or infrared frequency or infrared IR wireless communication. So whenever we think about having a wireless communication, then what happened? We say that we need this encoder to use it or interface with RF transmitter or IF transmitter. So it is commonly used for RF or IF wireless communication. Read that feature. Communication. Good. This, I see also Ht12E encoder integrated circuit. It is wide range of power. Another advantage, power supply. So it has what? A wide range of power supply. From what? 2.4 volt to 12 volt. If your neighbor is making noises, call your neighbor that from today I will call you an encoder. So if you agree to be called an encoder, then keep on making noise. But if you don't agree, stop murmuring. So then students, we say that, let us read this first feature. Say 1, 2, 3, let us go. It is what? Again, 1, 2, 3, read that important feature. I told you that electronics and telecommunication engineering is all about numbers. Whenever you see a number, 1, 2, 3, let us read the first feature. No. Again, read it loudly from Oro to Brighton. 1, 2, 3, 4, let us go. Brighton, can you read yourself? So it is a wide range of power supply. What does it have a wide range? Ht12E encoder. It has a wide range of operating power supply. So let me just add operating power supply. Urasa, read it yourself. Urasa is not in the class. He was chatting. And he thought that I haven't seen him. It is a wide range of 40 operating power supply from 2.4 volt to 12 volt. What does it mean? What the meaning of that sentence as electronics and telecommunication engineering student? What does it mean? Seni, tell us. What does that sentence mean? Quickly. Simple. Samuel Ringo, what does that sentence mean? Samuel Ringo also is another student who is not in the class. Now, Dixon Mwacha, engineer. Mexina, tell us, what does that sentence mean? Alquino is back for the second time. Mexina, tell us, what does that sentence mean? Bloody? Yes, wide range of power supply. What does it mean? Ask your neighbor while Mexina is trying to tell us the meaning of it. Because the sentence is very simple. And we have discussed in semester 1, we have discussed in semester 2, but you forgot. Tell us, Mexina. What do you understand with that sentence, Mexina? Mexina? Latifa, can you help your neighbor? What did you understand? Can you speak loudly? Speak loud. Just speak loud. Don't worry. We are trying. So can you speak loudly? So now, Latifa has given us the answer of that question. So Latifa, speak loudly in English. Want to learn from you. And precious is your attention to listening. Shkuru, listen. And Latifa, tell us. Prolins. Repeat again for Prolins because he was not paying attention. What does this sentence or these features mean? Wide range operating power supplied from 2.4 volt to 12 volt. Tell us. Latifa. So 2.4 what? Oranges or 2.4 closes? So what does it mean? Yes. Okay, 2.4 volt it's minimum. 12 volt maximum. What does it mean? What does it mean? Why do we have 2.4 volt? What does 2.4 tell us and what does 12 volt tell us? You have already explained the response in Swahili. Very good. Keep explaining. Okay, thank you. Good try. This sentence means that it talks about this block. That's what I wanted, first of all. It talks about it. What should we, or what the Ht12E encoder receive? What should it receive from the C power supply unit? So the minimum operating voltage required by Ht12E encoder to encode information is 2.4 volt. Once it receives 2.4 volt, then Ht12E encoder can encode the information. Once it receives 3 volt, it can also encode the information. Once it receives 4 volt, it can encode the information. Once it receives 5 volt, it can encode information. Once it receives 7 volt, it can encode information. Once it receives 10 volt, it can encode information. Once it receives 12 volt, it can encode information. Once it receives 13 volt, it won't encode the information. It's going to burn out and it will be the end of the story. Limi, what did I say? Are we together, class? So you should not claim that the Ht12E encoder needs 5 volts. No. You may have 5 volts, you may have 9 volts, you may have 8 volts, you may have 10 volts. It will operate. But this is actual, this is the range for the power supply. It's not the range for the input data pins, binary input data pins. It's not the range for the output. It's just the power supply. You are disturbing my class. That will be the last time. So he said that they recommended, however, that has a wide range, but they recommended the power supply. The recommended power supply is 5 volt. Then number 5. The 50 feature said that it has low standby current. It has low standby current of 0.1 microampere at 5 volt. Number 6. There's Ht12E encoder IC is available in 2 packages. Namely 18 deep pins and the so we have also 2 important features of Ht12E encoder. The first one, it's a parameter we call it standby current. Say standby current. Say standby current. So the standby current is low for this integrated circuit, and it's just 0.1 microampere at 5 volt. So when you supply 10 volt, the standby current will be different from that one. That one is only in case of 40 when the supply or the power, the operating power or the power supplied to the IC is 5 volt. Then the 6th one is very important. How does it available? Because remember that we'll be focusing on learning integrated circuits by using the through holes architecture rather than surface mounting architecture, because the through holes is the one that we can mount on the breadboard. So he said the Ht12E encoder IC is available in 2 packages, namely 18 deep pins and the 20 SOP pins. What does DIP mean and SOP mean? For what you know about SOP, it means sums of product. There we don't have sum of product. DIP? What are the meanings of the word DIP? That abbreviation. It's abbreviations of which? Pardon? Multimeter? So let us end this workshop by just drawing the physical appearance of Ht12 encoder, and then I will leave the homework for you. Then we'll meet in the next workshop. That will be workshop 60. When we'll discuss about the remaining part for Ht12 encoder IC and the 433 megahertz RF transmitter module. So let me tell you what the means of DIP. DIP's abbreviations means duo in package. Duo in package. So D stands for duo, I stands for in, P for package. Then SOP, just to go and find. If you remain say that, oh, it means you have sum of product, that's all about you. But go and find the meaning or the long term of SOP. Oro! What's going on? Mwatatu, eh? Mwatatu. So then, physical appearance of Ht12, or first of all what T? We call T Ht12E deep integrated E circuit. But remember that for deep we say that 18 deep, because we say that 18 geo in package IC. 18 deep IC. Who is that you want to fall down? Who is that? Shane? No, Shane is sitting, relaxing at the boss of the class. And you know that Shane is fat? Say physical appearance of Ht12E 18 geo in package integrated circuit. Say it. HP. Student, this is HT, not HP. Not HP computer or HP as a head prefect. Ask your neighbor, were you the HP in your school? Ask your neighbor. Or the head girl in your school? To hear the lie of your neighbor. He or she wasn't even a monitor. Say, class, read. Physical appearance of Ht12E 18 geo in package integrated circuit. Say it. Percentage. Again. Is your neighbor really pronouncing what you are pronouncing, or your neighbor is just eating a pen? 1, 2, 3 letters. Read it. Some of you say deep. Okay. So the integrated circuit, hello, keep quiet and stop drawing. The integrated circuit, the Ht12E encoder integrated circuit, it has 18 pins, not 14 pins as AND gate or OR gate or not gate or NOR gate or NAND gate or exclusive OR gate or exclusive NOR gate. Itself, it has 18 pins, and another package, it has 20 pins. Are we together? So if it is 18 pins, you have to take 18 divided by 2. Now, precious, 2 divided by 18. What do you get? Yes. So Precious prepared 18/2. Okay, 18/2, it is what? Alquino, because now Alquino is in the class. 18/2 and 2/18. 2/18. We don't need 18/2. That's simple. Sonia, 2/18. 0.20. Ask Zuena to help you. So 18 over 2, it is 9, isn't it? A. So on left-hand side, we expect how many pins? 9 pins. On right-hand side, we expect how many? Hey, precious. Hey, 12 over 18. On right-hand side, we have how many pins? A. Gaudens. Makajoka. 1. Make sure that, listen. Hey, Carolina. So make sure that this pin is in straight line with another pin on this side. So you have to use a ruler to draw these pins. Okay? So I don't have a ruler, so you might find that maybe there are not aligned on the single straight line. Angelina, where is Gertrude? 1, 2, 3, 4, 5, 6, 7. Eh? Don't know. Can you call her? Jacqueline Balele, where is Gertrude? Eh? Call her. One, 2, 3, 4, 5, 6, 7, 8, 9. Shukuru, what are you talking to Eliakim? And how many pieces do you have? Separating? Elimi County, 1, say it, 1. Uh-huh. $18, eh? What are the names of these? Christina Mabeza. What the name of that? Eh? Mabeza. What the names of this pointer? Notch. Very good. Mabeza is in the class. Pasco, why are you laughing? Uh-huh. So how do we number? We number the piece Alquino. That is any time. Alquino, what is going on outside? Eh? Eh? Business. Which business? 3 times in a single lecture. Uh-huh. So how do we count? We count the number of the pins anti-clockwise from the notch, right? Eh? So this is pin number 1, then this is what you number them, smash those numbers so we can end the class, and then you leave the place. This is what for master, this is what are you master? This is what then Daniel Fortunato, this is number what 7. Then Pasco, this is number what Jacqueline, this number what 9. Carolina, this number what 10. Anastasia, this number what 11. Oro, this number what are you Oro? Eh? 12. Matatu, this number what Matatu. 13. Alphonse, this number what eh? Shane, this number what Shane. Eh? 15. Urasa. Zuena Masebo. Zuena Masebo, this number what those who are quiet are not in the class mentally. Then Omachi, this number what? And this one? 18. So what the meanings of 1 to 18? What 1 to 18 mean? Pin what? Class, 1 to 18, what does it mean? Pin what? Pin numbers. Say pin numbers. Pin numbers. Yes, integrated circuits, all the integrated circuits has the pin number, not pin names. Now I'm going to give you the pin names. It's just like yourself. You have registration number and the name. You see that how we design electronics? Pasco, can you take the bag back? Take the bag back. Because you have been sending to somewhere. Take the bag back quickly. So the pin name number 1 is 80. This one is 81. This is 82. This is 83. Sorry, not 8. 83. This is what? Nura? Where is Nura? Nura? A4. Then this is what? A5. What? A6. Today in this class, we have 2 students who are called Nation. Both of them are not in this class. Make sure them to attend tomorrow because their attendance is poor, especially the other Nation. And today also we missed a very important student called Abdullah. Where is Abdullah? He's sick. Are you sure? And Urasa, Amedeo is not present in case of Urasa's group. A7, right? But Mvunyo Suleiman is inside the house today. Number 9 is what? Ground. Benjamin Joseph is not present, and also Glory P. Maro is not present. So this one, we don't call it groundy. This one, we call it VACS. This we call them pin names. Say pin names. Pin names. And then pin number 10, the name of pin number 10 is called the 88. Say 88. Say 89. My dear students, I tell you that this week you are going to build a transmitter by using this encoder. So listen this information, ask a question. Okay. I invested more than 500,000 to make sure that I facilitate this practical for you. AD11. Then we have TE, and there's another pin name is called the oscillator 2. This one is called the oscillator 1. This one is called the D out, and this one is called the VDD. Those are the pin names for the HT12. And here we have HT12E encoder. You should not claim that all the integrated circuits are made by logic gates. So you should not think about AND gate within there. You know that you're expert on drawing AND gate, eh? Not T gate, you are drawing. There's a 4 AND gate. No. That's the combinational logic circuit, but it consists of logic gates and also some other electronic components. You may refer to schematic circuit diagrams in the data sheet. You'll get surprised because you'll find more than 30 electronics components built in within a single integrated circuit. So he said that this is figure what, student? A, figure 3. What its name? Low passing. Physical appearance. So 40 of Joan or physical appearance of Olenjolain, Can you explain the physical appearance of Olenjolain? No. And ask your neighbor, who is Olenjolain to you? Ask your neighbor, who is OLENJOLAI to you? Up to now, who is OLENJOLAI to you? Is OLENJOLAI your bestie friend or is your enemy? I like enemies, so in this class I have a lot of enemies. That is good. Enemies are good because make you to be strong. Rather than friends, because friends they will tell you, okay, you are good, good, good. No, no, no. Enemies are good. They will always challenging you. Okay. So pin number 1 to pin number 18, this we call them pins numbers. Or pin OT, pin OT, pin numbers. Say pin numbers. Say pin numbers. Then 80 up to 87. Then VSS, AD8 to AD11. Also we have TE transmission. We have oscillator 1, oscillator 2. Then we have D out, and also we have OT, VDD. So this one we call OT, this we call them pin or pins names. Pin OT name. So stop writing, let me explain about those pins and just relate to this block diagram. I said stop drawing, stop writing. For this case, we have A0 to A7. Say A0 up to A7. So A0 up to A7, this we call them address pins. Say address pin. Say address pin. So this we call them SOTI, address pins. Address pin representing this block. Mwatatu, mwatatu, mwatatu. Representing what? Please, Oro, make sure that you take care for mwatatu. Because mwatatu is getting lost while we are discussing important information. And that's why she became your neighbor today. So those we call this address what? Joshua, hey, you are drawing. So pin 0 to pin A0 to A7, we call them SOTI addressee pin. Say addressee pins. Say address pin. So those pins representing this block. Massa, bonsoir. Bonsoir Massa. Ça va? Comment vas-tu? Tu vas bien? Massa is one of the students who knows French, and I had her French during semester 1. L'éducation, c'est pas comme ça. L'éducation, c'est pas très difficile comme ça. I think for you, you haven't read Massa's message, but for me, I understood. Okay, so let us continue. Let us continue. So then we have VSS. Say VSS. VSS, it's abbreviations of voltage across source. Sock. VSS, just see for the space, because if you clean the blackboard, you will get disappointed that Olenjolain is continuing to teach. Voltage across, because God is telling me, Olenjolain, it's enough for today. That is good, God. Okay, so VSS is the voltage across what? Source. And whenever you see VSS, say VSS. In digital electronics means that the large number of semiconductor components found in Ht12E encoder integrated circuits are junction, just a field effect transistor, and most cases are MOSFETs. Because in field effect transistor, we don't have emitter. We have source. So the corresponding terminal is source. It's just like in case of the BJT, instead of finding the ground in BJT, we call it VEE. Means the voltage across emitter. In case of BJT, right? In case of FET, or field effect transistor, we have VSS. Means the voltage across source. Are we together? So if the large number of semiconductor devices that are being used here are bipolar junction transistor, you won't see VSS, you will see VEE. Or in some cases, we just call it ground. Bundala, are you there? What did I say? Bundala is not there. Then we have another one. So we discussed these 9 pins. You know them now? A? Okay. Then we come to these 4 pins. AD0, AD9, AD10, AD11. Fatuma, say AD9. Say it loudly. Say it again. Say AD9. Fatuma is majestically. Say AD8. AD9. AD10. AD11. Right? So simply, these are the 4 input data pins of Ht12E encoder. Lim is writing what she has missed it right when she was slumbering. So AD8 to what? AD what? This is what? Input. Data pins. So in case you have your input, you have your sensors. You have maybe your digital sensors. You have a flame sensor. Maybe you have maybe a speedometer. You have what you have. You have a fire detector sensor. You have your infrared sensor. You may connect them there. Okay? For our case, we are going to use the pull-down resistor network. There will be our input for our system. Are we together? Are we together? Eh? Then we are here. TE. Say TE. Say TE. TE, this is the pin we find in digital circuits whenever we are using that digital circuit for the transmission. TE is an abbreviation of transmission emission. Say transmission emission. No, sorry, transmission enable. Say transmission enable. So when you talk about AD8 to AD11, stop writing AD8, say AD8 to AD11. Say AD8 to AD11. We represented this block. Okay? When you spoke about VSCSC, say VSCSC, just represented part of this block. Are we together? So I'm relating the general block diagrams of the block diagrams with the physical appearance of the Ht12E encoder. Right? Are we together? So this is called transmission enable pin. Say transmission enable pin. We'll discuss it in the next workshop 60, about it. Workshop 60 or workshop what? Workshop 60. We'll discuss it. What does it do? And I told you that you'll find in digital electronics integrated circuits which actually use it for transmission. Right? This is the one that will be well interpreted by the decoder. Then we have OC, OSC2, and Omachi, stand up, and OSC1. Omachi, stand up. OCS2 and OSC1, this is abbreviation. OSC, it's abbreviations of oscillator. Say oscillator. So this simply, it is oscillator pin 2, oscillator pin 1. Say oscillator pin 2, oscillator pin 1. Say oscillator pin 2, oscillator pin 1. Okay, Vanessa Robert, tell us where do we find this oscillator pin 2 and oscillator pin 1 in the block diagram? Which block does it represent? oscillator unit. Very good. Clap your hand for her. Imara. Wow. Yes. It's good opportunity to be congratulated in the class and to be appreciated by intelligent students, intelligent people. You're very intelligent. Especially who? Edison. So these two pins represent what? Which block? Oscillator unit. Say oscillator unit. So oscillator unit. Then we have pin number 17. Say pin number 17. Say pin number 17. So pin number 17 is called, what is the pin name? D out. Jacob, tell us what D out, which block does D out represent? Jacob, hurry up please. We want to leave this class. Jacob, don't let us to be late. We are going to fight against you who made us to be late. Enabling, enabling transmission. Now, Toba Elias, engineer Toba Elias, at work. Tell us. Everything is on the blackboard. What are you looking from your exercise book? So D out, Latifa, sit down. D out, this is output pin. Latifa, I said sit down. Say output pin. Say output pin. So that pins is a pin where we are going to receive our binary coded information that we discussed in definitions of encoder. That the output of the encoder is binary coded information. For this encoder, at that pin, we are going to get a series of binary coded information. That series might be either, here we might have, if you have only one input, so we expect to have one output there. If you have two inputs, these two inputs will be supplied parallel to the encoder. And then those two bits will give or will leave out or through the out in series. Right? If you have three inputs, we are going to have 3 bits supplied in parallel. And those 3 bits will be actually taken out in terms of 40 series. If you have 4 inputs, then we are going to have 4 bits supplied to the Ht12E encoder. And then those 4 bits will leave through the D out pin in terms of 40 series. Are we together? So D out is simply represent what? Output what? Unit. Then you have VDD. Say VDD. Nema, tell us what the long terms of VDD. Very good. Voltage across, drain. One clap. Good. So this is representing voltage across drain. What does it indicate? You must sit down. What does it indicate? It indicates that that is, or the large or the main components of semiconductor devices that have been used to design or to manufacture this Ht12E encoder are field effect transistor. Because field effect transistor, it's a one type of the transistor that has a terminal called drain. And that terminal of the drain for the FET corresponds to the terminal of collector. So in case of collector, if you have used the BJT, you could see that the pin name here is called the VCC. Means the voltage across collector of the bipolar junction transistor. Are we together? So is it clear? So if it is clear now, I leave the homework. And that homework I won't write. I just pronounce it. Explain briefly how Ht12E encoder works. Explain briefly how Ht12E encoder works to encode the binary input information. How? You reply. So I would like to say that, did you understand, first of all? Did you understand the entire workshop 5? Have you understood or you haven't understood? If you haven't understood, we can restart the class. You have understood? Forget about that homework. What about what? Yes, okay. Now it's a time to appreciate you. Huh? 1, 2, 3. Hongera. Imara for understanding. Wow, for coming to the class. Ask your neighbor, when you miss the class, who used to congratulate you the place where you are? Nobody. These classes are good because they end with being congratulated and being appreciated. So the question is, explaining briefly how does Mvunye, I'm repeating the question. Oro, I'm repeating the question. Explaining briefly how does Ht12E encoder work to encode the binary input information. So if you have understood God saying that it's enough, I thank God who have given me this chance to teach you. I would like to say that this is the end of workshop 5. I think that you have got important information. I would like to welcome. Oh, yes, give that clap. Give it. Give the clap. I heard some students have been just providing the clap. Just give it out. Okay, so I would like to invite you in the workshop 60, where we are going to discuss some few concepts about Ht12E encoder. And once we finish it, we'll be discussing about 433 megahertz RF transmitter module. So thank you very much. May God bless you. See you in the next workshop.